Hi, we're ZkBlind. ZkBlind is a revolutionary platform that enables truly anonymous conversations for professions by leveraging the power of ZKP. ZkBlind ensures that users can participate in honest conversations without revealing their identities. What is ZkBlind? So we already have existing platform called Blind, but so all the verified professions can post messages on that platform. But the problem with the current Blind is that they still retain users' identities somewhere in their database. We want to leverage the technology of ZKP so that nobody knows who they really are, and people now can safely to post truly anonymous messages to the forum. How exactly are we going to do that? We have several constraints in our circuit, and we verify users' email, and also we parse the email, get some information from it. So altogether, we will get users' ID, users' email suffix, and also users' ETH address. Together, user can now be registered to a platform, then starting posting messages. So there are several constraints. The first one is that the user is SHA-256 of the user email address. This is not ideal for generating the user ID because we want to prevent people from guessing who they really are by looking at the ID, even though the ID doesn't show any information about the user email address. But imagine if you have a list of all the employees working for a certain company, you can do SHA-256 to all the email addresses, and then you will get all the user ID. Then you will know some certain user ID on a platform who's actually behind it. So this is not ideal, but we already came up with a solution to tackle this. So when we're generating the user ID from the user email address, we're gonna introduce some secret key, and the secret key will be split into multiple parts and distributed to multiple parties. So whoever wants to get the user ID, he needs to asking for multiple parties to get partial of the user ID, and together the user has the full user ID. And then when he submit the user ID, we can verify it is the correct user ID, but we don't know who is the email address behind it, and because there is a secret key involved, nobody can generate similar user ID from the user email's address, so the user ID is protected. So this is the constraint 1 for how the user ID is generated. The constraint 2 is that user email address is the sender in the email. So in our circuits, we have a private input for the email address and the private input for the whole email. And we need to have some regex circuits to verify that the user email address is indeed the sender of the email. The constraint 3 is that the user email suffix is the suffix of the user email address. We split them up because the user address suffix is the public input. We want people to know that the suffix of the user email address, but the user email address is private. With 2 inputs in our circuits, we need to have the constraints to make sure that the suffix is indeed the suffix of the user email address. Constraint 4 is user signature of the ETH address in the email is valid. So in the email body, we have the ETH address and also the signature of that ETH address. We designed this way to prevent that any random person can register using any arbitrary ETH address. That behavior should not be allowed. The user can only register for certain ETH address only if he knows the public key of that ETH address. So in the email body, we need to verify that the signature is indeed valid and he knows the private key of that ETH address. The constraint 5 is user ETH address and signature is the only email body. We have this constraint set to prevent the phishing attacks. Imagine that I send an email to you with some hidden message with my ETH address and signature, and you probably would reply that email back to me. Now I have your email, but with my ETH address and signature, so I could use your email to register for my ETH address and ETH address. This is not good, so we have to prevent this from happening. So we need to check that ETH address and signature is the only email body, so no one can be phish attacked. The constraint 6 is that user email DKIM signature is valid. DKIM signature is signed by the email server. So if I'm working for Apple and send an email from Apple email server would sign that DKIM signature to verify that is indeed come from the Apple server. So we check this to prevent the forged emails. Alright, so let's go for the demo. In order to register for a platform, first we need to write email from my address, from the company address to some other arbitrary email address that you own. So for example, I'm logged in as this email address, and I will have a message of this. So this message has two parts. The first one is the Ether address that I want to register with, and the second part is the signature signed by the private key of this Ether address to verify that I actually own the this Ether address. So with that, I send to my another email. So after you receive the email, you can click that button and download the message, download the whole email. I'll show you how the email looks like after you download it. So after you download, you can see this email look like this. You have like delivered to, you have some DKIM signature, you have some email bodies, and also from, date, and all those information. So after that, you need to run some commands to first generate the input. We wrote a parser to generate all the inputs for our circuits. So right now we have the user ID, user email address, user suffix, user ETH address, and this for the signature validation. So after that's being run, you can see we have the input file generated here, and then we will run a bunch of bash script to generate the proof of generate the proof of our email. So I already ran. It took a while to run the bash script. So I already finished the step 3. Step 4 is generate V key. Step 5 is generate the proof. Okay, so the proof, after the proof is generated, it should look like something like this. And also we have the public.json looks like this. So one thing that we could do and haven't done it yet is we have the smart contract. We can have the smart contract to receive all the string. Like for example, this is the user ID, but it's a big integer right now. So we want to implement such function that we can just input. Okay, so this is finished. So we can just input the user ID as like a hex or something like that, then encode it with the big integer, and so that the verifier smart contract can verify user identities with the input from with the parameters we give to the smart contract. So we also wrote a front end. This is our landing page. So after you click enter, you will come to this page. So we have, if you're not whitelisted yet, you can put the proof input and public input and click submit. You will be registered, and after that you will be able to post messages. We recorded a video to show you guys how exactly done. So after you click register, you put the proof input and public input. So right now we're using some mock data. After that's been submitted, we are posting this message to the Mantle testnet. Our contract is deployed into the Mantle testnet. So click confirm, and after being the transaction going through, and the front end detect that you have been whitelisted, it will show that the current has whitelisted. Now you can go to the ZkBlind page and click to post your messages. So I can see that if I want to say a new message, I click post, the new message is posted. And also you can see the ID and also the email suffix, apple.com. So now if you want to switch account to a different account, like account 8, you click register, same process, change the mock data a little. Okay, make another transaction. Okay, so now post another message. Okay, now we can see that another message is being posted with google.com and different ID. Yeah, so thank you guys for watching. Have a good day.